scholars. You guys chose the option for me to read it to you, which is awesome. Make sure that you are paying attention and annotating while I'm reading so that you are ready to answer the question at the very end of this document. Okay, let's get started. How do atoms rearrange? When you blow air through a straw into a cup of lime water, something happens. After a couple of breaths, the lime water is just noticeably hazy. After a couple more breaths, the lime water is definitely cloudy. After a dozen breaths, the cup of lime water is as white as milk. What turns the lime water white? Plain air bubbled through lime water does not turn lime water white. Something in your breath does it. Carbon dioxide. It is the carbon dioxide in your breath that turns the lime water white. That's not exactly right. Carbon dioxide isn't white, so it doesn't turn the lime water white. What happens is carbon dioxide mixes with something in the lime water to form a white substance. The white substance is not carbon dioxide or lime water. It is a new white substance. What's happening is a chemical reaction. During a chemical reaction, starting substances change into new substances. Starting substances are called reactants, and new substances are called products. Carbon dioxide is one of the reactants. Lime water is the common name for a solution of calcium hydroxide and water. Calcium hydroxide is the other reactant. You can set up a chemical equation to help figure out what the white product might be. The chemical formula for carbon dioxide is CO2. The formula for calcium hydroxide is CaOH2. The reactant side of the equation looks like this. This is how you read the equation. One particle of carbon dioxide and one particle of calcium hydroxide react to yield. What could the products be? The white substance that formed in the reaction did not dissolve in water. That's a clue. You need to see what insoluble substance you can make by rearranging the atoms in the reactants. Remember, calcium carbonate, chalk, doesn't dissolve in water. The atoms needed to make a calcium carbonate particle are in the reactants. You can move those atoms to the product side of the equation. What's left on the reactant side of the equation? 2 hydrogen atoms and 1 oxygen atom. These combine to form a particle of water on the product side. So you have calcium carbonate plus water. Notice that after the reaction has happened, the reactants are gone. They no longer exist. All the atoms that were in the reactants are now in the products. And the number of atoms on the product side is exactly the same as the number of atoms that started on the reactant side. During reactions, no atoms are destroyed or created. Matter is conserved. That means the number of atoms must be the same on both sides of the equation. This is a hard and fast rule. Written with chemical formulas, the lime water equation looks like this. The down arrow by the formula for calcium carbonate means the substance appears as a precipitate. The precipitate is a solid that separates from the solution because it is insoluble. You now know that not only do the type of atoms in a chemical reaction stay the same, but the number of atoms also stays the same because mass is always conserved. You can look at the number of atoms involved in the process of rusting as an example of this. The chemical reaction that causes rusting can be written as the following chemical equation. iron plus oxygen equals iron oxide. Another way to write the equation is to use the chemical formulas. 4Fe, which is iron, plus 3O2, which is oxygen, equals 2 iron oxides, Fe2O3. Using the chemical formulas, you can count the atoms on each side of the arrow to be sure that the number of atoms is the same. When the number and type of atoms are the same on both sides, scientists call the equation balanced. The number in front of the element or compound tells you how many atoms or molecules you have. In the equation above, the 4 in front of the Fe, which is iron, means that there are 4 atoms of iron. The subscript in the oxygen, O2, that little number, means there are 2 oxygen atoms in every molecule of oxygen, but altogether there are 4 iron atoms and 6 oxygen atoms on each side of the arrow. The atoms are arranged differently, but they are still all there. The equation balances because of the principle of conservation of mass. In a chemical reaction, the atoms rearrange, but the number of atoms always stay the same. So why does mass stay the same in a chemical reaction? Mass stays the same in a chemical reaction because the same atoms that are in the reactants rearrange to form the products. All the atoms are still there, so the mass stays the same before and after the reaction. Go ahead and answer the following question. What happens to atoms and particles during a chemical reaction? I already have your sentence starter right there. Just go ahead and finish that. Use some evidence from the text that you learned. Can't wait to see you in Zoom.